There have been entire books written about the definition of risk. We have books such as On Risk, About Risk, Risk, The Risk Society. Why is it so hard to define something which is so simple and so commonly understood by everyone throughout society? What we're going to do today is use a few simple examples to illustrate why no definition of risk is perfect, to give you some understanding of why it's a topic worth talking about, worth examining from a number of different disciplinary perspectives. At its heart, there are two main things that go into the common understanding of risk. The first thing is that risk really has to be something which is undesirable. Sure, people will sometimes talk about the importance of seeing the positive side and positive risk as well as negative risk, but that's not at all the way the term is commonly used. When we talk about something being risky, we're not saying, hey, it's a good idea, go do it. When we talk about something presenting risk, we're talking about it in some way being dangerous. So risk in its common parlance almost always means that there are negative consequences. But they're not definite negative consequences. If something actually, definitely, certainly hurts, we don't talk about it as a risk, we just talk about it. So risk always has some degree of uncertainty as well. Risk is something which we're not sure if it's going to happen, but if it does happen, we're pretty sure it's going to be bad. So let's take our most basic weapon for talking about uncertainty, which is a coin toss. We flip a coin, and the uncertainty involved is a strict probability. We know what the odds are. We know that when you flip a coin, there's a 50% chance of one result and a 50% chance of the other result. That's well known, well understood. No amount of investigation is going to make it more or less likely that the coin will come up one way or the other. But still there's uncertainty because we don't know what the outcome will be. Once we've flipped the coin, the uncertainty is resolved. But let's take a step further and say there's a possibility that it's not a fair coin. We don't know for sure, but we suspect that someone may have rigged the coin so that the odds are not exactly 50-50. What does that mean now? Well, now we've actually got two different types of uncertainty that are getting put together to make up the same risk. The outcome of flipping the coin is still unknown, and it will still be known after we flip it. And there's still actually a fixed probability. The probability once we flip the coin will actually be one thing or the other. We just don't know what that probability is. Maybe the coin is fair and the probability is 50-50. Maybe the coin is very unfair and the probability is 90-10. Maybe the coin's just got a slight edge and the probability of a heads is 55%, the probability of a tail is 45%. It's going to be one of those things, and it's going to be fixed. The coin isn't going to change mid-flight, but the probability is unknown. So we have a risk made up of uncertainty about the nature of the coin, and then inherent probability of the coin. Let's take another example that doesn't involve probability at all. We want to go and buy ourselves a loaf of bread, but there's a risk that the store might be closed. Here, the uncertainty is made up entirely of the unknown rather than the probability. If the store closes at 4 o'clock and it's currently 5 o'clock, it's not that there's some fixed probability that the store might be open or might be closed. There's just a gap in information. Once we know the hours of the store, the risk is gone. We know whether the store is open or closed. Information doesn't always totally take away uncertainty though. So how about the likelihood of side effects of a particular drug? You have a tablet that you need to take and you want to know what's the risk of a side effect. So some of this you can resolve with information. You can look up the different side effects that the drug has, and you can look up how much of the population is affected by those side effects. So some of your risk will be removed by gathering that information. But at the end of the day, knowing that a side effect is rare still doesn't take away the risk. There is still a probability attached to it. So in this case, we have uncertainty caused by a lack of information, but that uncertainty can be completely taken away. And then we have a fixed probability, which can be known by us removing the uncertainty, by us getting the information, but still there will be still some risk until we've actually taken the drug. This picture here is Deepwater Horizon, and we're using it here just as a generic example of a major accident. The interesting thing about highly complex technical equipment is that the probability of an accident happening from known causes can often be very carefully calculated. And that's the case with Deepwater Horizon. There are documents with hundreds of pages working out the likelihood of this precise event happening. But the probability of making a mistake in those calculations is also a risk, and that's much more uncertain. And then there's the probability of the explosion happening in a different way to the way it was expected. And the probability of an explosion from unknown causes can't be calculated at all. So we have risk, which can be calculated. We have risk, which is the probability of the probabilities being calculated incorrectly. And then we have risks which can't be calculated at all. These are just generic components. What's the risk of a component failing? Well, one of the things we could ask is how often has it failed in the past? But that doesn't perfectly represent how likely it is to fail right now. We could have just been lucky, we could have been unlucky. The rate of events in the past may not even represent the exact risk of the component. And then we have the question, well, how likely it is to fail right now still doesn't answer our true question, which is how likely is it to fail in the future? The final example I want to give you comes from one of the classic ways of talking about risk, which is the game of poker. So for those of you who don't play poker, it's a fairly simple game. Each person ultimately ends up with a hand of cards, and the person who has the best hand wins. So let's say that your hand in front of you near the end of the game has 4 aces in it. That's a very, very good hand. What's the risk to you that if you bet using this hand, you will lose? Well, you can evaluate that risk based on the odds of other people having different sorts of hands, and you might come to the conclusion that actually the risk of betting your life savings is fairly low. In the same game, someone else has this hand in front of them. Now, this is a straight flush. This is a very, very, very good hand. And the person with this hand in front of them is sitting back thinking, well, there are very few hands indeed that can beat this one. I have a very low risk of winning. I'm going to bet my life savings. Now, which one of you has a correct view of the risk? This person thinks that the risk of losing is very, very low. You, with your hand in front of you, also think that your risk of losing is very, very low. And someone who could see both hands will know for sure that the other person is going to win and you're going to lose. So are you wrong in assessing your risk as being low? Or are you right, but there are 2 different risks depending on whose hands you are looking at? This is one of the fundamental problems in understanding risk. Is risk about probability at all? Is it about probability and uncertainty? Is it about probability and uncertainty and about information? And how does subjective impressions of any of those three things come into the equation? So to understand risk, we need first to think about, is risk a real thing? Does it exist out there in the world somewhere where we can go and look at it and find it? Or is risk subjective? Is it something that we each hold in our own heads, informed by information coming from the outside world? What's the relationship between information and risk? Does risk always go down when you have more information? Or is it possible for extra information to increase risk? If 2 people measure the same risk and they come up with different answers, does that mean that at least one of them's wrong? Does every situation just have one risk that is negotiated between different points of view? Or can you legitimately hold different but equally valid points of view for the same underlying facts? And when we talk about uncertainty as part of risk, what does that mean? Is uncertainty a mathematical thing? Is it a psychological thing? Is it both? Is it neither? So hopefully these examples have given you some understanding at least of why risk is a subject worth examining. There are many more questions about risk than simply looking at a particular situation and asking what the risk is. Fundamentally in this course, we're going to ask what risk as a whole is. What is the concept? What does it mean? Can we define it? How do the implications of defining it in different ways lead to different actions when we take actions based on our understanding of risk?